All right, so example 9 says, given that x cubed plus ax squared plus x plus 6 is equal to x plus 1, x minus times x minus 2 times bx plus c, where for all values of x, we're to find values of a, b, and c. All right, so let's do the expansion. We have x plus 1 multiplied by the product of x minus 2 and bx plus c. All right, so right by the x plus 1, let's multiply. We have what? Bx squared. Then what? Cx. We have minus 2bx and minus 2c. So what we have is x plus 1 multiplied by bx squared plus cx minus 2bx minus 2c. We're going to multiply all the terms on the right by x. So we have what? Bx cubed. Then we have x times cx is cx squared minus 2bx squared minus 2cx. Multiply all the terms on the right by 1. So we have what? Bx squared plus cx minus 2bx minus 2c. Let's group like terms. We have bx cubed. Let's get all the terms in x squared. We have what? We have cx squared minus 2bx squared and plus bx squared. So that is minus bx squared. Let's get the terms in x. We have minus 2cx and we have plus 2cx. So this is minus cx. We have minus 2bx. And I think lastly, we have a constant term, which is minus 2c. Now, we are told that this is equal to x cubed plus ax squared plus x plus 6. All right, let's try and make our life a little easier. We have what? Bx cubed plus factor out the x squared. We have c minus b x squared. We have minus c plus 2b x minus 2c is equal to x cubed plus ax squared plus x plus 6. All right, so if that be the case now, let's see what we can find out immediately. We can determine what b and c is immediately. And b and c, let's determine what b and c is. B is equal to 1. B, of course, is the x cubed coefficient on the left. So this is the x cubed coefficient. The x cubed coefficient on the left, b, is equal to the x cubed coefficient on the right, 1. C, the constant term on the left is minus 2c. Sorry about that. And this is equal to the constant term on the right, which is 6. Divide both sides by -2. And we get C is equal to -3. And this here is from, we're comparing the constant terms. All right, let's go for A. A is the x squared coefficient on the right. So A, the x squared coefficient on the right, is equal to C minus B, which is the x squared coefficient on the left. So A is equal to C, which is -3, minus B, which is -1. So A is -3 minus 1, which is -4. If the signs are the same, you add and keep the sign. So I got A is -4, B is 1, and C is -3. And your answer, my answer differ greatly. I guess we could always look into that. Let me finish 10 and then we can go back and look at comparing your answers with mine. All right, let's have a go at 10. Again, it's an issue of comparing polynomials, comparing equal polynomials to determine unknowns. In 10, they said, given that 3x squared minus 5x plus 4 is equal to lambda into x minus 2 squared plus mu into x minus 2 plus phi. Now, lambda, mu, and phi are Greek letters. So I get used to them from now. You'll probably see them a lot. Lambda, mu, and phi, they are Greek letters. Now, for all values of x, we're to find the value of lambda, mu, and phi. All right, so let's work out what the right-hand side work out to. So we have lambda into x minus 2 squared plus mu x minus 2 plus phi. X minus 2 all squared, so this is lambda. X minus 2 all squared is x squared minus 4x plus 4 plus mu. I guess we could do the distributive law here. We have mu x minus 2 mu plus phi. Let's remove the bracket by what? Applying distributive law. Whatever is in the bracket is multiplied by what is immediately outside the bracket. So it's lambda x squared minus 4 lambda x plus 4 lambda plus mu x minus 2 mu plus phi. Let's group our like terms. We have lambda x squared. Let's get all the terms in x. We have minus 4 lambda x plus mu x. Let's get all the constant terms. 4 lambda minus 2 mu plus phi. Let us maybe factorize a bit. X squared minus, and we have what? 4 lambda minus mu x. You can always do a quick fact check in your head to see if yes, if you remove the brackets, if you get back what was there. And to the right, we have what? 4 lambda minus 2 mu plus phi, of course, which is your constant terms. So this we're told is equal to what? 3x squared minus 5x plus 4. So obviously, lambda is equal to 3. This is the x squared coefficient. All right, and 4 lambda minus mu, which is the x coefficient on the left, is equal to 5, which is the x coefficient on the right. I didn't bother put the both negatives, negative, negative. It's not necessary. So 4 lambda minus mu is equal to 5. We already know what lambda is. So from this, and this is x coefficient. So from this, I can say 4 times lambda, which is 3, minus mu is equal to 5. So 12 minus mu is equal to 5. 12 minus 5 is equal to mu. So of course, I brought the mu on the right in order to make it positive. And so what I get is mu is equal to 7. All right, so we have lambda, we have mu. Let's figure out what is phi. Of course, 4 lambda minus 2 mu plus phi is equal to 4. 4 lambda minus 2 mu plus phi is the constant term on the left, and that is equal to 4, which is the constant term on the right. So this is 4 times lambda, which is 3, minus 2 times phi, which is 2 times mu, which is 7, plus phi is equal to 4. This is 12 minus 14 plus phi is equal to 4. This is minus 2 plus phi is equal to 4. So phi would be equal to 4 plus 2. Minus 2 on the left goes over to the right and become positive. Phi is equal to 6. So mu is 7 and phi is 6. So so lambda is 3, mu is 7, and phi is 6.